Hello, hello, everybody. I believe I should have everyone live on Facebook and on YouTube Live. And with me today, I'm going to bring him in now. I have with me Scott, and he's going by La Quarantine, which I completely understand in this working from home environment where we all are.
Yeah, I'm permanently stuck in between parentheses right now.
So, yeah, I think we all are. I've been working from home. My day job's been at home since December anyway, so I eased into this pretty easily.
Yeah, I think it's a lot easier for us coders who, we're spending a lot of time just needing to be, long unbroken spells of silence. So it's kind of working out. But yeah, when you really do want to go out, you don't have that option now. So it's like.
Yeah, I think it's been the toughest for my family. For me, I'm okay if you leave me in a room to code for a few hours, but for them not being able to get out for weeks on end is pretty rough.
Yeah, it's definitely going to be rough.
But for anyone that doesn't know here, this is Scott, and he is what title do you like to go by? Project maintainer, lead developer,
maintainer. Yeah, I'm maintaining, definitely maintaining. And lead developer or whatever. I'm basically the guy who edits your stuff when you submit it and make sure that it's all pretty. And then I occasionally submit stuff of my own and try to break things and see what we can change and make better and all that kind of stuff. So yeah, I'm all mixed up in many roles, but yeah, the day-to-day is maintaining.
Terrific. And I'm sorry, I've got too many windows and tabs open here. I'm going to have to close one. I was just making sure that we were still live, and we are. Everybody's commenting. So appreciate everyone in the chats for joining me and Scott today. I originally tried to get Keith on, and Keith was not into it.
Oh.
He told me to contact you.
Really, Keith would be a good person to talk to, and he's like,
see, I thought so too.
All up in every issue. He knows all about everything these days.
So Keith is actually in the chat, so I appreciate Keith joining us anyway.
Okay, we got his voice. Good.
No, I completely understand people not wanting to do this. It's not for the faint of heart. You never know how it's going to go. Personally, I like the live streams. They are less work than the edited videos.
Yeah, and you can always, take your live streams and edit them later and turn them into something.
There you go.
If that's your aim. So
I read your background. Your background is heavy in the everything coding. I saw that you had I think some of your oldest stuff, not counting the stuff that a lot of us started with, which was basic programming and machine language coding on Apples and Ataris and things like that. But you also did some video game work. Is that correct? Yeah,
back in the day, every kid wanted to be a bedroom programmer and transition from writing their clones of Pac-Man that didn't quite work to writing, real things that really worked and, getting into the industry or whatever. But so, at that time there wasn't a lot, but I was, the early 90s, you had Amiga, you had some IBM PC, a lot of games were up and coming. So that was really happening time, and I just happened to fall into that whole Amiga thing at that time. And I did a couple titles. One was Dino Wars, which I keep a copy of on my wall here.
Oh, very nice.
Which I was able to get on eBay.
So not an original copy from actually when you worked on it.
No, well, it's that old, but yeah, it came from someone who apparently purchased it. And then I did from that. I worked into a job where I got to do the clone or the Amiga version of Bill and Ted's Excellent Adventure. And that's been widely panned as being a very unplayable game. And so it was actually, in fact, both mine really were. They didn't get the benefit of a real team effort and play testing. It was very much that lone thing. And without the feedback, they didn't turn into strong games. But it was a good experience. I learned a lot. And a lot of it comes into use now when you're writing low-level code for these embedded processors. A lot of them are in similar speed ranges to the machines of that era. Right. So it's kind of when you optimize, you're doing the same kind of tricks.
I'm guessing most of those were 8-bit chips, right?
Yeah. Well, the Amiga was a 16-bit or you could say technically a 32-bit processor, because you had 32-bit registers and things, and the bus sizes varied from machine to machine. So they were either technically really 32-bit, or they would use tricks and maybe really have a 24-bit bus. So it came down to how much memory you could access. But under the hood, yeah, you had these chips which were really kind of cool. They had, you went from something like a 6502 with just an accumulator, an X and a Y, and maybe the 0 page, if you want to count that as registers, to now having, a bunch of general purpose registers like and a bunch of address registers. It was really kind of neat. And then all this memory to play with, and then all this speed, and then these coprocessors to help you, which that used to be a thing. You'd have a coprocessor to help you along with stuff. Now everything is done either by the CPU or with some, general purpose other processor kind of sharing along.
Yeah.
But in the day you would write a lot of custom stuff, and nowadays maybe FPGA can fill that in. We'll see. We'll see.
That would be new on the 3D printer front. I haven't seen any FPGAs yet. Have there been some independent work on those, or some one-offs?
There was some buzz about those ideas at ERF, but it's sort of still in the realm of buzz. It's sort of like what can be done. Like just looking at what how you program them. Just between myself and the other people I was talking to, we saw it was very quick to whip together, say, a stepper handler that could manage multiple stepper and build all the counting and all that, because ASICs are perfect for that kind of thing. Just maintaining counters and sending signals based on those counters would be a perfect thing. And that's the kind of thing that you can offload really easily. So those sorts of things are actually being built into stepper drivers to some extent, like your 5130s and things have that stuff in them. But they're not widely used because they're not in part because they're not widely understood, and maybe in part because you kind of need to do these synchronizations and changing of speed dynamically a lot, and they don't necessarily accommodate that. They may be great for a short linear motion, but when you need to queue up many of them, it becomes kind of more of a bottleneck. So I don't know. So, FPGA could fill a lot of that in.
Yeah, and I would love to stay on things like that all day, but I don't know if we'll keep most of our audience if we do. So if people were wondering, FPGAs are basically programmable pieces of hardware. So instead of running software on a general purpose CPU, you can write code that essentially programs the gates on a programmable grid array, as they call it.
Yep, exactly. And
I did that in college, but that was the last time I did VHDL.
Yep. Just gates that, based on whatever the other switches are doing, they let other signals through. And if you just put them in the right order, magic happens.
I enjoyed that. We used to have to code like robots in school using, ASICs and stuff. And that was a lot of fun, but that was the last time I got to play with them. Yeah,
it's kind of like, there's a crossover between coding and programming. And that kind of fills an interesting gap because you start to see that, there's logic involved. Whereas if you're looking at a circuit board with a bunch of hot components, you don't necessarily see what's going on. So it's kind of
I started my college career as a computer engineer rather than a software developer, and then I made the transition over as I saw what jobs were available.
Yeah, probably, and also just how quickly things change, and also the depth of knowledge you really need to even begin.
Yeah,
can be really daunting. Whereas with coding, you can more or less keep up. And if you if you need to take a vacation and go work in web coding or do something else, you can do that. And it's very general. And you can
I think the only thing I've learned is that you have to keep up with languages. Which is why I stay in the C realm as much as possible.
I guess we're supposed to know Golang now, or Go, and a few other things. But of course, we're supposed to know our neural nets and things. And
the whole world's on Python.
Our quantums, But if you know Python, you're kind of everything because you can just plug into all the libraries or whatever and jump into those worlds. So scripting is good that way.
So people in the chats that are waiting to potentially ask some questions, we're going to hold those to the end because I've got a fair amount of my own, and I don't think I'll be able to keep up with the questions. So if you have questions, just hold them to the end. I will let you know when to ask those. So let's do a little Marlin history. I think we're going on, I don't know, like 6-8 years worth of Marlin at this point.
Well, technically, you could say I feel like it's been at least 9. something in that realm, because it first came together with I think Sprinter in that at that time, thanks to Tonikip and others bringing that all together. And then, although he may not have had direct involvement in that effort, but it came together well because there was this whole LCD thing that he had done, and that sort of fit well with the Gerbil stuff, and then it all just sort of coalesced. And so, yeah, it's been pretty much that time. I think, I don't know what was being used exactly at around in the 2006 era when the RepRap project kind of got rolling. But
yeah, I've never looked that far back to see what they wrote. I'm guessing those are mostly dead code bases at this point, maybe absorbed by other trees.
Whatever Cupcake is running, I don't know, probably. So yeah, in that realm, and then yeah, so a lot, and it just basically snowballed from there. It just slowly got more and more contributions, and sort of grew and grew and grew.
So what was your first architecture that you were running on?
Marlin in particular?
Yeah, Marlin in particular.
Marlin, of course, is running on the Arduino library on your typical Atmega hardware and that kind of thing. So you could almost get it to fit on a 328p. Gerbil, I believe, fits on one of those. But with all the extras, you basically would have to move up to at least a 64K RAM or flash space, and then from there, as it grew, it kind of became where you really needed a Melzi or 128-bit K board. And nowadays, it's good to have a Mega. So at the time I started playing around with it, I was running it on, just your ramps on a Mega standard, whatever. I think I even got it from Arduino.cc. It's just like, that was what you did at that time, and it worked fine. Had actually a lot of room. You had all this flash space that you regretted not filling up. Like, what am I going to do with it?
Right. Nowadays, that I guess you're filling up even 256 if you try hard enough, right?
There's a lot of menu items you can add. those strings, they add up a lot quickly.
Yeah,
so that's the big part of it. Yeah.
Yeah, I was noticing on the what is that? The Big Tree Tech. They've got what is supposed to be a 256K chip that apparently you can force it to do 512.
Well, it's not Big Tree Tech in particular, but it's sort of the
that's the ST32.
Yeah, it's sort of like a lot of chips. They're like aftermarket. When you buy them, they're marked with a certain thing that says it's good enough to use for this much. We can't guarantee that but some of these are actually bigger chips that just got tested, and the upper part of the RAM didn't seem good, or maybe the lower part didn't seem good, so they just flipped a switch in it in such a way that it could only use one of those banks.
Right.
But the switch is not a permanent switch. You can actually get around it and flash it how you want. You're just taking a risk because that memory was found to not be reliable. So probably at some point you might find your print just stops working and you don't know why, and then you'll be calling us. It's usually I just want to strongly recommend people don't do that unless they're feeling experimental and they just want to see. Always be mindful if you have done that, and if you've done that, don't give your printer away to somebody who doesn't know without flashing it back to something safe, because they won't know, and it's like a real hassle when it just suddenly doesn't work.
And that's good advice, because that actually came up in a Facebook group that I was in, and someone was asking, is this a 256K or a 512K chip? And I look at all the data sheets, and every data sheet is saying 256K, but then there's that underscore 512K that you can set it to in the configuration file, and so people have been doing that, and so there was a bit of confusion, and I typically go off the data sheets.
Yeah, and who knows what components might come in the future as we start to become more cyberpunk in our coming together of parts. These things may become, very much of a piece, and you'll just get parts that maybe don't quite fit, but you try. And so we allow you to experiment, but yeah, definitely, I'm going to start marking those with an asterisk in auto build or something.
It's probably a lot safer.
Yeah, maybe not an asterisk, something really scary, a crucifix. Yeah.
Something where you really have to turn it on.
Crossbones, yeah.
Put that secondary if-def in another file that they have to go turn on.
Yeah, it's you can set that stuff up in through platform.ini. You can build options, and you can get around build options that maybe aren't supported directly there.
Okay.
Scripts that can then change things, and you can get very fancy with it. You can even write special uploaders if you need one for your special device. So there's a lot of interesting features there to explore. I'm just starting to get into the debugger, and I haven't even, well, to be fair, I haven't even got it really running. So that's the first big challenge.
You haven't gotten what running yet?
The debugger, like the actual real-time debugger.
Okay.
Running on the board, and most of the time I'm doing stuff. I'm just like printing messages out.
Oh, it's
the console, and that's
in general
a fine way to
faster.
debug sometimes, but
I mean, I'm the same way.
Yeah.
When I write code, printfs are usually a lot faster and cheaper than trying to open up GDB or something.
Yeah. Well, I've got this ST link, and I really want to get deep with it, where I can really follow the flow and start to, just because a lot of that is just getting it in your head. It's like if you play with the code all day, it's fine, and I get it. I know what's going on. I run it, and I can see what's going on. But between those two spaces, it's just like this blank, and I just want to see it kind of happening in real time on the screen, and with the oscilloscope and everything just all going, so that I really get that overview and can just like jump into the stuff that's next level, which is coming up. A lot of next level stuff now with the new chips and stuff.
Yeah, and we're going to talk some more about that in a minute, because I have some questions about where Marlin's going. I've been looking ahead in the branches and stuff, and so so let's talk a little bit about. I wanted to talk a little bit about the process of developing Marlin and your involvement with that. So first up, so what is the process, like your process at least, or maybe the community's process of like when you're getting bug fixes in, when people are submitting patches, are you actively involved with reading all of those fixes before they're actually committed or merged in, however you handle that merge request? And then besides just reading the code and seeing what they've done, are you involved with actually testing those to make sure that they do what they're supposed to?
A little of both. Well, a lot of both. I spend most of my time is spent actually reviewing submissions of either new features or fixes, understanding them and trying to integrate them if they are something complex or whatever in the best way, and then suggesting changes and finding ways to make them not break compatibility, and making sure that things like new features that might print stuff out to the host are okay with the host developers and things like that. Just kind of there's a lot of coordination between myself and like the community in general, sort of with this sense of what is needed, especially with, it comes down to like new devices and new printers and new features that are out there. And so there's sort of like this push to get them all working and within the open source world. So if something comes out proprietary that's cool, we want to have something that, maybe mirrors it so that we can all partake and maybe extend that state of the art and make that feature better or that peripheral better or whatever, or maybe explore new ways to do it, whatever it might be, whether it's a filament sensor or whatever. And there's a lot of really cool innovation that comes out of, just people suggesting things and trying stuff. And but there's a lot of so from day to day, as those things come in, I'm like, having to make sure that they fit and work well. And then I'll take pull a printer out and install it on one or another and make sure that it does what it's supposed to do to some extent. If it's more complicated, I need to do like printing, it's going to take some days. Like a pull request will hang around for longer. And so until it gets more feedback from other people. And by virtue of things being around and having a connection to other types of issues that certain people are interested in, because they have a certain printer or a certain LCD or whatever it may be, certain people will tend to come in and help out. There's a lot of folks right now, especially involved in like the STM32 world, which we're talking about, but that's a big area just because there are so many new things coming out around it. And each one is slightly different. But also just, there's the day-to-day of like, well, this doesn't seem logical. What do you think about that? And discussing ways to kind of just get things more modernized and more polished and more logical and more consistent. Then there's like, So within that realm, like, that eats up a good half of the day just dealing with, all that kind of like stuff. And then I'm kind of like left with, okay, what can I do to contribute my like or whatever into that? And so for the rest of the time, I'm sort of like either trying to integrate those features or exploring those ideas or trying out things or working on maybe getting some particular printer that isn't completely working yet, working to kind of get that idea in there. So yeah, it's a constant. Like from day to day, I have to say it's quite scattered because I don't necessarily know when I get up in the morning what it is I'm going to be working on. It's usually like, okay, what I was yesterday plus whatever falls from the sky today. And so it's always an interesting mix, and you always have to be adaptable to whatever the next thing is going to be. So knowing about each piece somewhat intimately helps. Knowing something about the LCDs and the chips, the how the different libraries all around all work, and all the devices and your LEDs and things. And yeah, you just have to kind of get your head into all of it, and it falls into place after a while.
Do you have a favorite part of the code that you like to work on? I mean, do you like the lower level, the hardware level stuff, or do you like, the math or complex curves?
Well, I enjoy that stuff to some extent, because when you get it working and you see that you've got some idea you had, and it has to run at high speed, and it can handle running at that high speed. Oh, I need to do this 12,000 times a second. Will that be okay? And it turns out, yeah, it's fine. Right. As long as it makes it better and saves something somewhere else, you're good. So it's kind of cool when that happens. But most of the time, I'm like, trying to get myself to the point where I can okay, let's get this stuff working. And now I can focus on the higher level things like the interface and things like the first time setup wizard and things like that. And integrating higher level things like more axes. Mm-hmm. All of these things are things which require kind of a big break and a higher level overview, and sort of getting away from all the other stuff. And that's kind of the stuff that I really long to work on, as much as I long to get it working and improved, because that's a big area. And I know there's a lot we can do there to improve the user experience and just make these things more approachable and less difficult to recover from errors and things like that. So
when you're integrating a new feature, something that, and this is transitioning directly off of what you were just talking about, when you're integrating a new feature, particularly if you're worried it's going to be particularly processor intensive, is there things that you potentially haven't left out, or is there a minimum standard that you have for performance? Because now that we have such a wide range of processors, everything from really small, low 8-bit processors to these new 150, 160 megahertz, 32-bit chips, are there features now that you could do that you couldn't do then, or things that you would enable now but maybe like limit to certain architectures?
Well, at this point, given that you have 32-bit power, and at any time, we could have taken advantage of that since it's been available. Sure. To do things like, for example, SmoothieWare has this option to bring in the the Wi-Fi interface off the SD card and stuff. Mm-hmm. Like, you can do stuff like that, and you could, all the things that are being done on 32-bit processors, and even to some extent on Raspberry Pis, could be brought in on these 32-bit boards with it, where the space is available and where there's enough power available. But what we're using a lot of that power for is to give you like much finer motions, so you get down to as close to like single steps as you can get, where it's making, like, if you have a curve where it needs to be smooth, you can break it into smaller segments and things like that. So using the power that's left over to do that, and not interfering with that, is kind of a good idea. We're not taking advantage of like the multi-threading libraries and stuff, which have been, for example, Prusa Firmware is actually a fork of Marlin that they then took and they use a, basically an RTOS, a real-time OS, probably a simple open one. I haven't really looked too closely.
So you're jumping ahead, because I had questions about RTOS and multi-threading. So
yeah. So getting into that general idea, without getting too deep, is just that that's one realm that, could be explored, because then you have, okay, well, you just divide up each process into its own thread. And we explored that sort of as like RTOS within Marlin as an idea, where we had a thread system within it. But it seems to make, I kind of like their approach, where it's like, well, you could have, you have a task which deals with the screen, and that's over here, and that gets its time. And then Marlin gets its time. And if you really want, you can split out the stepper. The tricky part becomes in data sharing. And that's just like, how do you deal with it? Do you do messaging, blah, blah, blah. All those things become tricky when you have to deal with many architectures and many types of screens. It's like we're, in a way, sort of stuck where Microsoft had been for a long time, where the architectures were tricky. There's no standard, quote unquote, BIOS, but there is sort of like, there is kind of, in a way.
Yeah, so warning to everyone that's watching, if you're not technically inclined about OS design, we're going to get into some of that here.
Yeah.
But if you have your own questions, save those to the end, like I said, because some of this is the stuff I wanted to ask about, and I hope that there are some people that do understand what we're talking about and find this as interesting as I do, because me personally, one of my focuses in school and ever since, because I'm a Linux guy, has been OS design. And so all this scheduling and multi-threading, and it's the stuff I really enjoy doing personally. So, so right now you're talking about, this was a question, and so while we're on this topic, we'll go ahead and get to these. So right now, is mainstream Marlin single-threaded?
Yeah.
Okay.
Big loop.
It's a big loop. And how do you handle the time slicing, since you said that right now you're not doing really that, and it's not even time slicing really, I guess.
Yeah.
I mean, you're kind of...
All time is used, essentially. Basically, it goes around a loop and sees what needs to be done. And basically, it's sort of like, you could say it's like, it is optimal in the sense that, like, if you were writing like a real-time OS or whatever, it'd have to be really general. And as a result, you do sacrifice some speed, you sacrifice a lot of RAM, and you end up sacrificing to have a little space set aside for this blob of, handling everything. But for that, you gain some simplicity, and your architecture can actually be simplified because of some of these things. So having I'm actually thinking in the terms of sort of re-architecting in a new way, but because of everything that is sort of in place, doing that with what we have and having it work while taking it apart is kind of like, having a running city while you're, disassembling all the streets. You couldn't necessarily, do that. So it's like that. How do you balancing? Where do you start over and where do you fill in? Becomes a real challenge, and especially as things are being, constantly piled on top. But yeah,
I noticed that you had and this goes into that too. I noticed you had a fork, not a fork, but a branch, where you had a Marlin 2.1 Marlin RTOS. Has that been set aside at this point then, or is that being actively worked on?
Yeah, it was a very minor experiment in taking, and as what I was saying, like, it's basically spin off one thing, like the temperature ISR currently was a interrupt service routine, and just have it run as a thread off the real-time OS bit. And then, you could do that with each bit that you wanted to spawn. And it's because of the way we had it running, we kind of needed to have the stepper stuff still be locked to the interrupt service routine. It needed to be very low level, so that we had the most optimal performance, especially for AVR. But on the top of the 32-bit, you can sacrifice some of that again and just, slice up your time using the RTOS. And it all comes down to how performant is that, and then you can play with that. So, but as you go from one architecture to the next, I think a big problem was that we also needed to support all the architectures within one code base and build on that. And that was kind of the idea. Was really, it wasn't necessarily meant to be like, we intend this to be the perfect, approach, and it should be taken all the ways, but more of an exploration. If we build it this way and we build an underpinning that makes it work, and it's a big old loop instead of an RTOS, what do we learn out of that? And can we still see the structure of the thing? And especially exposing the structure and breaking it up into the pieces kind of was a major part of it, because it was a bit too monolithic, as they say, one big file. Almost. And so it was like, yeah, let's split it up and start to get a sense of the big picture. And so we have a sense of that architecture, and others have explored that. But each time that they do, it tends to be very hardware focused. It's towards one machine, and they get it all great, working great with one, but then getting it to work with the whole family of all the different boards and things is, yeah, that's one of the main challenges. Again, it's just always, there are compromises, and we try not to limit ourselves. Like if there's something that could be only 32-bit, we allow it. Let's have some only 32-bit features, because it's clearly like there's stuff that could be done with a lot of thinking or heuristics or look ahead, or maybe even, AI of some kind.
Yeah.
There are, reasons to use that. But we've kind of gone another direction, and you'll probably ask about this too, which is like Klipper, which offloads processing to Raspberry Pi.
Yeah.
We now have an option where you can do that in Marlin, where you can just have you have a daemon that is a separate project, which goes alongside this Marlin, and you run that daemon on your Pi, and then Marlin can just get the signals from that, and you run your G code through that. And so now your 8-bit board is doing, much less work.
So is that available today?
That's available now. Yeah, that's been on bug fix for about a month, but it had been hanging around as a concept for a couple of years before the developer really had time to like catch up with all our changes and kind of get it in there just at the right time, really, because things are stabilizing in that way, and we have a much richer sense of how to do that now. So
how does that project compare to Klipper? Not necessarily which one's better. I'm not asking for comparison as much as, feature wise. How does the project compare?
Well, I imagine Klipper. I must be honest, I have not played with Klipper, but I've looked at some stuff around it and read about it, and it looks cool. It seems to have a nice it has an interface of its own and everything, and it looks like it's very professionally done. And of course, the whole idea there is not just to offload the printing and make it super smooth by having more power given to your card, but also to be able to then explore advanced other advanced planning.
Right.
So that's sort of similar to what we're doing too. Is it's up to the person who writes the daemon and other people who want to work on that part of the project to explore what can be done in that advanced planning area, because you send it off to the printer and there's no cost. The printer can just do it. As long as the segments aren't shrunk down to be super tiny so that you're like killing the printer. You give it enough room and just send as much as you can, and it'll do it. And that's kind of the cool thing, is there's a lot more room for exploration there. Then that's so I'm excited to see what's going to happen. The developer Colin Argadzi is really cool and really into this stuff, and has done a bang up job, as they say. He actually put together an Octo print plugin in a weekend, and now that's out there too to help get this.
Okay, well, I'm going to definitely take a look at that, because I had not heard that was available yet. So
yeah, I had kind of made some noise about it on Twitter, but yeah, it's all about, I guess in this community, it's all about the buzz. We just got to
yeah, it is
t-shirts that say Marlin or something with a big.
What's it called? Does it have a name yet, or is it just
Step Demon?
Okay,
is the name of the project on GitHub, and
so it'll sit alongside on your Raspberry Pi with Octoprint, and they will interact and play together.
Yeah, and actually it does some optimized communication with over USB and everything, so that everything gets there as quick as possible. Right.
Okay, good. Yeah.
And what was the other cool? Oh well, yeah, G6 is the code we ended up using for that, which is a fine choice. I had been using that occasionally to do direct stepper moves, and that's kind of what it's meant for. But in different contexts, it can mean different things. So it seemed a good use for it here.
Okay. Awesome. Yeah, because I've had a lot of people, particularly after those last videos. I know you saw the last one. A lot of people recommending that I try Klipper and wanting to know what I thought about it, and I haven't tried Klipper yet either. I've got OctoPi on the corner of all of my printers here, but I haven't wanted to override it with Klipper yet.
Yeah, well, if you try this one, you might get in ahead of Chris Riley. So.
Oh no, he might be in the chat. You may have just created a challenge.
Yeah, that's right. Head to head.
So what? This is one that, let's see. It's transitioning from that videos that I posted. Let's go ahead and step over to something people are probably interested in. The traditional jerk versus junction deviation. I think that we can answer. I answered this in my video, and we can answer it here. That junction deviation is getting fixed, so that won't be broken.
Yeah. Right now in bug fixes, it's not bad. There was some stuttering on curves that's been remedied with the lookup table version.
Okay.
Yeah.
And so I've read a bunch of articles, and so I'll leave my 2 cents out of it for now. But what's your opinion on just where do we stand on traditional jerk versus junction deviation in terms of which one? I mean, people are going to want to know which one should they run once they're both working equivalently. I mean,
yeah, I have all kinds of, like, I'm sort of ambivalent in the sense that, not in the sense like, I don't mean apathetic. Some people use those words interchangeably. What I mean is I'm sort of back and forth, because sometimes I think, that junction deviation has a special quality that matters even on printers where you have your y-axis is one weight that's moving by itself, and your x-axis is another weight that's moving by itself. Somehow junction deviation still meaningfully mitigates that. But I feel like using traditional jerk on a Mendel style machine with a moving Y bed and a moving X gantry, and maybe even on your XY cores and everything where you have a moving gantry and another part where these things are somewhat decoupled from each other, it may be better to use jerk. Reason being that you can specify jerk separately for one another.
Right.
And say, my Y bed is really heavy. On the other hand, you can also specify that sort of by using acceleration. You can kind of get away with the same idea.
Yeah.
And the other thing is, too, that jerk as a concept is really just instantaneous change in speed. And so you still have to mitigate things like corners, and you still have to decide how to slow down on corners. And junction deviation sort of matches up the fact that you're dealing with corners and you want to change speeds, whereas jerk really only looks at the final result of, okay, here's how fast I'd like to go, and then it just sort of attenuates each of those axes based on how fast it'll just say, you can't do that. And so it's sort of like the machine is always trying to push the edge with jerk, whereas with junction deviation, it maybe is trying to mitigate it a little earlier, catch it a little earlier, and maybe, but the problems arise when you have, and this is probably the same in all cases, when you have really tiny segments and you're making a curve, maybe you're making a 90-degree turn, but it takes 20 segments to do it. So the look-ahead buffer doesn't have enough. Yeah, there you have something with your 32-bit board and maybe a bigger buffer. You have the ability to do more look-ahead, and so you can kind of like see, I'm not going to be able to make that speed 20 ahead, so I should be pulling back for all these moves. On the other hand, that 32-bit board result that you got on your Batman bust has a lot to do with the fact that you're just getting less aliasing.
Yes.
Because your Bresenham is working better. It's like less, for each X and each Y, you're getting smaller, basically splits, I guess.
Yeah, absolutely. And this actually goes directly into another conversation I got into. I think it was in the comments of that video. Yeah. Which I'm going to phrase it a little bit different than the comment did, which is where the intersection is between what your slicer is doing and what your firmware is doing. Yeah. Because I noticed when someone brought it up that the Cura has 0.05 millimeter slices or segments that it does, which seems extremely small. And I'm sure we could do some some very, in the back of my mind, I was saying that we could do some very careful coordinating to like whatever step size you were going on your stepper, whatever your micro stepping was. Right. Obviously, you could align those in some sensible way because obviously one or the other is going to be your largest value. Right. But when it comes time to mitigate like what is my printer capable of versus, what am I trying to tell it to do?
Mm-hmm.
Like the slicer still plays a pretty major role in how much data are you sending to your printer and expecting it to keep up.
Oh yeah, when you, for example, set up your slicer to do segments of curves that are, say, 0.1 millimeters in length, your Cartesian can probably keep up with that with a character display and maybe at a pretty reasonable speed. But as you start to build up more complexity and you want to go to higher speeds and things, that's gonna bog down the printer very quickly. So you have to decide, am I going to upgrade my board so it can handle these small things,
right?
Or am I going to, tell my slicer to back off and stop trying to tell my board to do things it can't handle? The other thing too is that if you do send that stuff off to the board, sometimes the firmware will be like, well, I can't do segments this long or this quickly, and so I'm going to wait until the segment is long enough that I can do it, and so your curve will actually get cut off, and so you'll get, choppy curves or things that jump over gaps where you don't want them to. Even though they'll be very tiny, you can still see them. Sometimes they show up as little curly blobs on the sides of your printer.
So that's built into the buffering where it'll throw things away that it doesn't think it can handle?
Well, if the segments are too small, there's actually a lower bound you can set and say, beyond this you shall not go. Every segment must be larger than this, and therefore I will wait until you give me another move before I go. And so, for example, if you have like a tiny segment that's the end of one move and then you're going to go a big line across the thing to do something else that's just a plain move with no extrusion, you might get no extrusion on that last segment because it's going to jump straight ahead to that last bit that has only a tiny bit of extrusion on it, and then it'll just, be over that long line. And so that's not what you usually want. And there's no way to necessarily mitigate that where we can say, oh, well, we're going to chop it off and make another segment here. We tried to do that in some places, but it's not really the place of the firmware to do that. Slicers should anticipate the kinds of problems that may arise from literal interpretation of their instructions and deal with it. But of course, every time they try to do things, sometimes they can make the mess worse by sending lots and lots of feed rate changes, lots and lots of acceleration changes, and all these things, which just bog it down more. So. Yeah, that's another question too, as to whether or not to do these sorts of things.
Well, I mentioned that in that comment chain was how similar. Some people. Oh, it wasn't the same comment, but it was the idea. Why are certain, why are the newer versions of Marlin running slower than the older versions? And it's kind of that same idea, the same reason that slicers have the same problem, which is, well, it's like all software. We continue to add features. We continue to try to make it better. And some of that causes problems when you end up with too much code for these older chips.
Yeah, I mean, to some extent, I've tried to avoid anything that would add overhead and try to use tricks wherever possible to keep things running really well. And to some extent, I think I don't know, it's an interesting question. We should probably do some, real world comparisons since we have the versions out there to see how the performance is and stuff. And there'll clearly be things like bugs where you can observe like funky bumps in the oscilloscope output of the steppers or whatever in some versions, and that have been fixed in later ones. And those will be evident. And you could really do a pretty neat comparison looking at all of them and looking at all the different ways they perform given the same, G code. And you could maybe find some interesting ways to time that. For example, one thing I've tried to do is like use, if you're going to get signal timing, the best way is to trigger pins and use an oscilloscope. So if you need to see how fast the steps are performing and how quickly it gets from the beginning to the end of this thing or whatever, just toggle a pin and hook up an oscilloscope, and that will give you the best output and the best view of what's really going on. But anyway, that being said, I think that in general, what we see now, especially with like junction deviation, has overhead. There's a new lookup table version of it, so that adds, that costs more memory or flash, but it's faster. So that's, if you look at like the latest version, there's optimizations there. The number of actual optimizations that are possible at this point are They're actually not a huge number because there are so many tricks we've already employed. You could do stuff like the integer planner and make a version of the planner that's integer, like more fully integer, and get rid of some of that float math that's in there. And but again, that comes with complications too, because then you're dealing with the conversions between floats and fixed and whatever else you're doing. So yeah, it gets messy. So overall, though, I think that now that we have cheaper 32-bit boards, are really good performing versions of Marlin, solid ones where you can just pick out, like 116. That works fine. Other people have stuck with 114 because that one worked great.
Yeah.
And there are a few shaky areas because we were doing a lot of trying to fix things between 118 and 119, for example. Skip 118. 119 has a beautiful fix for the stepping, and so yeah, like a lot of fixes came in at just the right time. Stick with what works for your machine. Get a good solid working machine. Don't feel pressured to go with every upgrade.
Well, and that's what, and I try to tell people that a lot, because this concept of upgrading, and you're just upgrading because it's newer, it doesn't make sense in firmware. This isn't Microsoft Word where you're going to be getting a handful of bug fixes and features. If you're not seeing any problems with your printer and you're just upgrading because, hey, there's a new version of Marlin out, you could be causing yourself problems.
Yeah, and I mean, I wish you could, do a thing where you could say, "Oh, I'm going to look through the change list, and I just want this one fix. I like my 115, but I just want this one fix."
Yes.
203. Darn. How do I get that? And sometimes you can actually apply it because
I'm going to just cherry pick that one item out of Git.
You might have to do it manually and figure out what the real names of things are now, because we rename things a lot. But figure out what's going on. And the patches are there to reference. So yeah, if something really is suitable for you, we can usually pick it out. But that's the cool. It's one of the cool things about this is you have that whole history, and you could go back and see where we figured things out, and see where the things said optimize, or we did something and it broke something else. Definitely hold a feet to the fire when there's something that you really need and it gets broken, because the last thing we want is to step on stuff, especially older things that it's not getting used a lot. They get stepped on by mistake. I don't like that to happen, but it does happen.
Yeah, but I'm with you. I mean, having these public source repositories where you can look up every little change and figure out where something may have gone wrong is really beneficial. It's beneficial to, I guess, mainly for people that care about the code and want to go in and backport something, or find out why something might be broken, or look for an optimization.
Yep, absolutely.
But are you still taking this is just an offshoot, are you still taking bug fixes for the 1.1 tree? Are you still doing any maintenance on 1.1?
Any major bugs that are will be put into the 1.1 tree. I haven't been doing any 1.1 releases per se with a number on them. We're just patching 1.19, so there's sort of like you could call it 1.19 dot.
I saw 1.191 was the version I downloaded.
But yeah, it's been patched a little bit. And yeah, the idea there is to just keep 1.1 where it is, and 2.0 is sort of the idea sort of was that if you built 2.0, it would be about the same size and with the same performance, with the same features. And if it is bigger and fatter and weirder, then that's something we should try to tweak, get it back to that, make it.
Yeah, and that's what I was a little confused by in my testing, because I did see that as I went up from 1.1 8 to 1.19, I was seeing 1.19 seemed slower than 1.18 did. At least in my testing with my configuration, and maybe this is very dependent on what you're putting it on and what configuration and what test print, and I know how variable things can get.
Yeah, no, I mean, I would love to see again a total comparison of the two side by side, because I am fascinated by that era, especially because there were a lot of interesting fixes that came in at that time. And, I know that 1.19 is better in that sense. You'll get better results from your prints, and not as much stuttering and stuff. So that's good. And the layer shifting was the big deal around that time, as I recall. And
is that why they added the timing for all those steppers? And I noticed that there were some timing changes that were added in some in the configuration advanced file where you could change the.
I mean, wow. There was a huge overhaul actually at the time, around the time when we added S-curve acceleration, and just dealing with, and it was an overhaul to the way that end stops were dealt with, and at the same time that necessitated splitting up the whole stepper thing into a couple of different phases. So you had your, stepping phase came first, and then all your figuring it out what to do next came after, and that turned out to be better. So, you fill up all this time with, after you've done your stepping, instead of having your stepping be uneven. It made it much more regular. And so stuff like that was done. But as a result, I don't imagine that the performance was helped by that. But it was.
Well, that's honestly where I thought I saw that possibly come in, was when you started. I don't know if you're doing delays there because of those stepper interactions. I haven't actually dug down to the code. I just saw the settings, and I noticed that there were timings in there, which when I see timings, I think delays.
Yeah, well, I mean, I guess I would wonder, like, if you do a move that's 100 millimeters per second, I'm going to get really dopey here, but
no, that's fine.
Millimeters, 100 millimeters per second, and it's for, like, the width of your bed on 118, and then you do the same thing on 119. We're not saying that it's slower on 119. That move will still happen in the same amount of time. What we're just basically saying is that maybe you won't be able to do 1,000,000 segments.
Exactly. Maybe. And that's what I was getting on the Batman, was the 1,000,000 segments.
And that's kind of the idea, is that maybe there's some stuff going on there. I would, again, it's water under the bridge at this point, because we have these versions there, and it sounds to me like 116 fortunately doesn't exhibit too many issues. We're not seeing layer shifting. That's good. Like, if it's working, good, great. But if you compare them, like, I would be fascinated to see just generally where things got fixed, because that's really the proof is in the pudding.
Right.
If you could really actually have a whole data set where you see a graph. Oh, look at all these. How many screen bugs were there? Well, 72. Now we're down to 12. Oh, back up to 12, 40. Up, back down. It would be fun to see that ebb and flow. But it comes down to, like, how ambitious are we in trying to fix or change or improve things? And the more ambitious we are, the more likely we are to break stuff, or otherwise, hopefully temporarily impact performance. Because the idea is to, really get, okay, what's going to work here? Let's do everything. We'll throw everything at it, and then we'll try to optimize it on the back end. And that's not unusual in software development. But you do end up with these cases where it's like, so that last release was a little slower, and then you're not going to get the best performance out of it. But
there were a whole lot of features that you're going to love later.
Yeah, and you can even run 119 on, like, some 32-bit boards. So there's some fun things could happen out of that. But the cooler stuff happened with the adaptive step smoothing. I always get a tongue twister on that. But adaptive step smoothing was the thing that really made a big difference there, because then we're slicing up time and improving the resolution, essentially. It's like the difference between your normal display and your Retina display. You're really getting finer resolution.
Okay. So. To that data point comment you made, I think that was the developer in me getting really excited in my last video, where I found a data point that could correlate what I was seeing physically on the model, which was where I was able to correlate the quality with the amount of time it took to print. And the faster it printed, the better the quality.
That's unusual. Well, it's going to depend on your settings. Like, maybe you were dealing with an ooze problem, and you just, because you printed faster, all your ooze ended up being
No. This was all these Batman that I was doing.
Yeah.
And it was definitely that it was some sort of skipping or pausing or something remember, with all those segments that we're talking about. Yes. I think it was having processing problems on those curves.
Yeah, there's actually the zits issue. That's actually part of, there was a bug in Junction Deviation. So you're actually probably seeing,
this is without Junction Deviation.
That's without JD?
Yeah.
Well, without JD, then you're dealing with segments being just overwhelming the planner.
Yeah.
And so
that's my guess. That was my hypothesis, was that it was because of just what I was trying to throw at the code.
Yeah, there's a slowdown option, and if you make your buffer a little bigger and then make the slowdown something like 1/3 the size of the buffer, something like that.
Okay.
Quarter the size.
I know which settings you're talking about. Yeah.
Yeah, the idea there is that you can have it slow down when it's got it's still got 10 moves, so that as it slows down for those 10 moves, it's got plenty of time to fill the rest up. And so instead of getting that zit, you just get this sort of, the thing about the slowdown, I think, is that it's not gradual. It's sort of, it instantaneously slows down.
Yeah. So what I was worried about, I mean, how much back pressure
of the next move is slowed down. So yeah.
How much back pressure would you have to worry about with the sudden slowdowns?
Well, it's less than with a stop. So I'll give it, we'll say that.
Okay. I'm going to have to try those out and see how they turn out.
Yeah. It's definitely better than a stop.
So another feature question. So one of the things I also covered in my video, and I wasn't able to reproduce this myself, but I know it's a known issue, and I know you mentioned it, which is, why are linear advance and S-curve acceleration, why are they separate features? Why are they mutually exclusive? And do they have to stay that way, or is it just that way today?
Well, the issue is that actually S-curve isn't predictive.
Okay.
We don't know how much time an S-curve move will take, per se, ahead of time. We might be able to guesstimate it, and we might be able to come up with some table based on just running it on a bunch of common cases.
Mm-hmm.
But at this time, it's not predictive, and so that's been part of the problem, is that because S-curve is basically, it's doing the slow ramping up and then slowly slowing down, you have longer heads and tails of your moves, and as a result, what the linear advance is doing is sort of not matching up in time with that. And usually, what we usually do is we know that a segment of a linear move is going to take a certain amount of time. We know that a certain segment of your extruder, therefore, is going to take a certain amount of time, and then we just put the extruder movement, sort of compress it in between that time.
Mm-hmm.
And so it's sort of like, that's still possible, but because of the way it works and because of the way that the numbers are tracking each other, S-curve actually is within a block of assembler, of hand-tool assembler, and we can't introspect the values it's using in the way that we would like to, and they have a different meaning, and it's a little bit of a mess. I'm sure someone with a deeper insight into how it all goes together, or more time to study it, could probably get it, like, have an aha moment and get it working. But that's mainly the issue, is that they just they are sort of at cross purposes to each other. The whole purpose of linear advance is just to and it also can move over and left and right. It can start early and end late, and those movements are separate from each other. And that it can even run outside of the gap of where your linear movements are. So it gets a little weird. So hard problem. So we're lazy. I guess that's the only answer.
No, and as we've talked about it here, I mean, there's so many things, so many rabbit holes you could go down. So it's just, what are you feeling like that week? I mean, to the question of, I would love to run tests on all of these things we've talked about, but it's plastic and it's time, and there's only so much of either.
I'm actually, I really want to go down certain rabbit holes, but again, that's what happens, is anytime you go down one, you sacrifice all the, the other little things you could be doing. So, but it's amazing what people will show up with. Someone will come up with a whole bus full of new code, and where have you been?
Again, they found a rabbit hole that they were interested in chasing.
Yeah. Oftentimes, it's just some fork that I had no idea existed. So that's just.
So what happens? Just because I'm curious, what happens if you enable them both? What does the code do?
Enable which both? I'm sorry.
The S-curve and the linear advance.
It's just weird. It gets weird. Also,
end up with weird math.
Yeah, and also
kind of stepping on each other.
If you're gonna, and it just, it doesn't necessarily look or sound good. And also, you're dealing with especially with trinamic steppers, it doesn't necessarily like the timings and stuff. The other thing about linear advance is it can oftentimes go backward, where you don't where you wouldn't expect that to happen, and so you can't. And we can't S-curveify the E.
Hello.
Thing was S-curveified ahead of time. which is how it works, and then maybe LA came into play somehow. The way it works now, it's sort of like when you have linear advance, it gets separated out into a whole different process for managing an extruder.
Okay.
And so it's kind of like part of that is just those families haven't met and gotten to know each other well enough to intermarry. So
does linear advance, does it work on each segment, or is there some sort of like look ahead to the next segment that's going on linear advance?
Yeah, linear advance kind of works on a spring-like kind of concept where it's looking at like it considers a complete move to be sort of like acceleration to deceleration. And so, yeah, each linear segment does count, but the way that it works is it has sort of because of the way the segments are joined, it becomes continuous when segments are continuous. And then as it gets towards the end, the pressure comes into play. And that, of course, comes into how you attenuate with your K value, which is based on I forget how to tune it, but there's a whole guide.
Yeah, I know. I've seen the guide.
And the easiest way is to run the test code
and
just do that.
Okay.
Because then you can just pick the numbers that look right, and you don't have to know the theory at all. But yeah, it's a very interesting thing. But the essence of it is that it basically is, it's trying to mitigate the fact that you have pressure buildup, but it can't deal with things where you have unusual pressure buildup, like too much water in your filament and things like that. So,
there's no pressure sensor in the end.
Yeah, there may be cases where your filament maybe of the type where it swells the longer that it's in the chamber. Yeah. And their prediction becomes very difficult because you may have moves that it has to move and stop, and during that time it's still swelling, but you can't necessarily account for that unless you've got a different profile for each material.
Well, and that's one of the things that I've wondered about. I think I'm probably like a lot of people where a lot of these settings, a lot of these features are really cool and you want to implement them. But once you start realizing that some of these features, such as linear advance, has a lot to do with how fast you're printing, what material am I printing with, and then all of a sudden you realize that your K value list is going to get kind of long as to like, okay, I'm printing at this speed and this material, and these were my good K values, and it makes printing less predictable or more of a I guess a task where you have to, like the slicing feature, putting things in your start G code, things like that become less of a I guess it gets out of that appliance mode and back to a CNC machine.
Yeah, and I guess my early mantra on Marlin was, and still to some extent I try, is keep it dumb. That basically it should be obedient to whatever commands you give it, and basically carry them out in its and only really get in your way when there's safety involved, and not try to be too smart, because you can do so much in the slicer to do things like linear advance is something that the printer can do it, and we're glad it does. But it's complicated, and it comes with extra complications that I've heard about through a Prusa-Birdie, but which I haven't implemented the fixes for yet. But yeah, there's it's a complicated thing, and it just adds more difficulty to how the interactions between your slicer and your printer. And that's really where the problems come in, is because it's like anything where you have the butterfly effect. There can be something is fine as long as it's left to its own and with the type of inputs you expect. But as soon as you start fiddling with it and start running clever slicer output through it, you get some weird results that you will not expect, and that kind of like throw out the whole purpose of the feature sometimes. So if your slicer can do things and deal with things like the pressure inside the nozzle and stuff, because it knows the machine you're dealing with and the material you're dealing with, let the slicer have all that expert knowledge, and don't pressure yourself to try and set just the right LA value. If that becomes something that's very standard and we have a very good control on it, which we do. I mean, it is just a certain behavior that is predictable. Every line given the same way will do the same thing LA wise.
Right.
So we have it in hand. It's just a matter of learning how to have that interact with your slicer, and have the slicers understand it so that they can talk about it. So Prusa slicer, now that it has, they have the whole ecosystem, they probably can tune LA directly, whereas most slicers don't go near it. That's up to you to tune linear advance. Same with your things like firmware retraction. You can tune it, and that's kind of a cool thing because you can adjust it while you're printing, which is great. But will it always work? Sometimes print slicers can be smarter and realize, well, you need less retraction for here and more retraction here.
Right, depending on how big of a gap are we talking about. And I mean, we've all seen that where, I mean, particularly on the larger beds where you've got a long travel. Well, you probably should have had more retraction there because it's eventually going to ooze out the end. But retraction based upon move distance, things like that would be more intelligent.
Right, and the whole theory behind linear advance was that you would not need much retraction at all. And yet there actually is kind of this whole range. You need a little, but not too much. Same with jerk. You need a little, but not too much. Like they go together. Jerk,
yes,
and linear advance and all those things, whether it's junction deviation or jerk or whatever, all those interact together because you're dealing with things like how fast does it do that corner, and what's going on with the pressure, and what are your top speeds, and how is your acceleration working. Even your acceleration can come into play and how long is that move. It's how can it even reach the top speed, because most of the time your printer will not. Small beds, small objects, you're dealing with, you might be able to reach 20% of your top speeds with those small moves. If you try to go too fast, you're going to shake your printer apart.
Right. So,
so you're just having to deal with those limitations, because it's all about speed and space and time. It's all about space and time.
And so I'm going to go ahead and ask Michael's question here, because this will be I'm about out here. But Michael's question is the general question that everyone wants to know. So if you get to choose between S-curve and linear advance, what's the right answer?
Well,
or I think the better question, what variables help you make the decision?
I would say if you're going to use S-curve, leave your linear advance stuff to your slicer.
Okay.
And experiment and see if you can get it to work well, because your slicer won't know about this S-curve stuff, but it might have some things you can do with that, some advanced cool features that deal with it, especially now. There's so many things in the slicer, and you're dealing with even things like the size of your segments. So it's not just tuning things like speeds, but size of your segments, and I don't know, there's other very fiddly features inside of slicers. So but think of it always in terms of just the 2D layer that you're making, those and then think of it in that terms of that one-dimensional line, and just keep it simple. And then is there going to be a blob at the end of that line, and do what you can to try and get rid of that blob. Or do I care? Maybe you're doing types of moves where I don't care, so I'm going to be messy here.
Right.
I can go really fast, and then know it here in my outer perimeter. That's the only time I'm going to go nice and slow, or whatever. You can get away with a lot of really cool things and have your prints come out looking gorgeous, and no one will ever see the mess inside. So there's a lot of that. So I would say with that, if you're going to play with junction deviation, start out with just, use the tuning form on the website and the test, and run that, get it tuned well to the common thing that you're going to be printing. And then tune it with the thing that you're printing. And then be ready to throw out the value, but it'll probably be similar, but be ready to throw it out. But it pertains to like the length of your tube and all kinds of other things. It'll also pertain to your material type and whether the material has a perfect diameter. Usually they do now, so you're good there. All kinds of other factors come into play. But yeah, and how springy it is, and how much it, how quickly it melts in the chamber, whether you get back wash in the chamber and stuff. And all kinds of other things come into play as well. A lot of people aren't aware, but if you will regularly get one of the things that causes jamming is when you're trying to push the material too fast, and it's just like you think it's going to be a clog, but it's not. It's just materials backing up because there's nowhere else to go, and so it creates a jam, and as it cools, because it or heats and cooks, so those kinds of things can happen because we're trying to push the edge all the time. So I would say whenever you're tuning any of this stuff, start at the slowest rates and get your stuff really looking good. And then, if you're going to turn it up a little, and start with just the feed rate, spin the knob and go
Yep.
up 10%, 20%, feel it out. And then you'll see that some parameters are more affected by those changes in speed than others. And you may find that just, dialing back your acceleration on one of the axes is all you really need, or whatever it may be. It's a very inexact kind of art and science combined. And so and again, the more variables you add, the more your soup is going to have a mix of complex spices. And you're going to be like, I know what that is, but I'm not sure. It could be cinnamon. It could be cardamom. I'm not.
So Michael wanted to clarify. He was specifically asking: is there a preference of linear advance or S curve if you are printing at speed? 100 mega.
Well, at speed. Well, okay, at speed. I mean, again,
100 millimeters per second, 150 millimeters per second. We're talking.
Yeah,
I think twice what I normally print at.
I mean, they start different names. One is like S-curve acceleration will let you reach higher speeds, but you have to have higher accelerations to reach those higher speeds. And so it kind of but also it kind of messes with linear advance. So the thing is, I would say if you've got a big printer with a lot of weight on it, then you should be using an S-curve acceleration.
Okay.
And then you should be tuning your slicer to get the best extrusion you can get. And if you're going to use linear advance, use it sparingly, just catch that, because you can tune it to a point where it almost doesn't seem to be there, but it is. And you'll notice it in very subtle ways, but so you can mess with that. But find the settings where it doesn't do much of anything and then kind of work around those. So then, I would say if you don't have a big printer and you don't care about the weight of the things and a lot of weights being thrown around and other stuff, and higher speeds, then linear advance may be the thing to use also for that case, because
so something like on a Core XY.
Yeah, like on a Core XY. Again, I think jerk is fine on Core XYs, and I think jerk is fine on Mendel style machines. Although again, I'd say experiment, because junction deviation is just, it has a certain dynamic and a certain feel, and you'll hear a certain whining sound that goes with it. And if that feels right to you and it seems right and the objects you're printing, it fits, then I would say stick with it. Get tuned to that kind of resonance that feels good. S-curve has a definite sound to it that I like, but a lot of people find a little weird, because it's like, if you have silent steppers, you won't hear it. But if you have whiny steppers, it's weird. It makes them sound more like servos.
Okay.
It's the only way I can describe it, or something. They spin up. It's odd.
So I want to save a little time for questions here. So I'm going to do, I guess, a quick, we're going to try to do short answer on these remaining questions, even though I know some of them are not short answer. Speed round, so that we can answer some questions in case people have been saving them up. This ties into the question that we were talking about earlier in terms of moving to more of a traditional OS-based scheduling model versus a single-threaded model. Any chance in the future of multi-core processor support?
As multi-cores come on, yeah, we could definitely split up the thing. It would end up being 2 binaries essentially. Well, no, I guess not 2 binaries, but multi-core would basically be, we'd be able to run this. We would have to get onto a threading model,
right?
And so
so at that point, maybe that's the thing that tips over, where you have to move to some sort of scheduler.
Yeah, I mean, my feeling about this whole question of modernizing the code base is that there actually are some really good code bases out there that already exist, like, for example, RepRap firmware. And maybe a better approach would be to get it working on more architectures and then port more features into it so that it works on more displays and is more complete. And then kind of build on top of that so that you end up with something that is like when Gerbil and Sprinter met and joined into one thing called Marlin, or Sailfish or whatever else would have been out there. These things took on a life of their own. In the same way, I think that those make a good basis, and that all they're really missing is that broad appeal, because they don't run on anything but, say, Duet, and maybe a couple of other boards, maybe a couple other do boards.
Yeah.
And then and maybe a smoothie can run it now. I'm not sure. We'll see. But yeah, so as these things, because rewriting Marlin from the ground up is like, it's such a multi-stage process. It's like you have to go through evolutions, or you have to go and rewrite it from the ground up. And it's sort of like, there are ways to split up, definitely, because there are entry points in Marlin. And it's like you could almost imagine doing it, but it's always that contention. Like, if this thing is running in quote unquote parallel with that, and they need access to the same info, you always have to make sure that they're playing well together and stuff. It's not, I've worked with that stuff before, semaphores and all that kind of thing, locks. It's fun. It's a joy.
I love that stuff.
Be calling on you.
Okay, call me.
But yeah, well, I don't know if we would go that low level, but that's kind of the thing, is like, if we could do it on the RTOS level, I think that would be the way to go.
I think that'd be a lot of fun.
Yeah, and there could definitely be RTOS offshoot. And
then you get to play with different types of schedulers.
Yeah, I'm actually thinking, rather than spin off 2.1, that the next revision should really be 3.0, and we should look at something that monumental. But it is huge, because if you look at everything in Marlin needs some kind of formal representation, down to what is a feature, what does it mean to have a setting, what does it mean for something to be edited.
But it does make things sound a lot more modular. I mean, it'd be a lot easier for someone to bring a module to you and say, you plug this in here, and this is where it goes in your pipeline.
Yeah.
So I mean, it could, I think, maybe spur a little bit more development.
Exactly. I mean, I feel like, I'm working definitely from the top down and from the bottom up, both simultaneously.
Yeah, no, I understand.
As you want to impose a kind of a structure, but in essence, like, what would you say would be the model that we're building? Is it model view controller? What is the pattern that Marlin is built on? The firmware pattern? It
is firmware. It does firmware things.
Yeah, like a pattern, for those of you who don't know, is just in coding, you decide, okay, I'm going to build an app. And so you decide, okay, one part of my app is going to take care of all the data. And my other part over here is going to do the interface. And then I'm going to have this bit in between that sort of connects the two. And you build these things together. And you call your interfaces your view. So it shows you stuff, and then you interact with it. And then your controller talks to your view, and then your model is your data. And so you build stuff around that. And most everything is built around these kinds of ideas. But then you have, is it going to be event-driven? And so then if you have an event-driven architecture, then you have something that's sort of like sending messages out, and then everything is like listening. Oh, did that event happen? I should do something. I care about this event. I'm going to register for it. And like, you build this whole architecture, and then you build your stuff on top of that. Well, that's not how Marlin or Gerbil were made. They were made, for these tiny embedded processors. And so, yeah, as we're building up on top of that, it's a loop. And it was built to embedded C++, which meant you couldn't even do stuff like use malloc or new. You're just, some libraries do, and you accept it, but they do it at the beginning, and that's it. You never free up that memory or try to like reallocate and free and shuffle or keep.
That's just good embedded design.
Yeah, that's it's good. You don't want to be wasting a lot of time doing that, because that's overhead as well, and garbage.
Well, plus that's how you run out of memory all of a sudden when you didn't expect to.
Right. So there is this vast menu of things we can pick from in application world and in desktop application world that we could build Marlin like, but it's not an application, although it has application-like aspects. It's more like a client server kind of situation, because you could say that it is a server, and you log into it with your screen to ask it to do things, or you log into it with your host.
Yeah, no, I definitely think of it. I mean, when you play with it, it's definitely comparable to, I guess, what most people would think of like an HTTP server. You send it a request, and it gives you back what you asked for, either in actual feedback or in the moving of a motor or something like that.
Yeah, exactly. And so in that way, but then, when you really abstract it out, I mean, what I'm talking about is go see a lecture on CNC, and that's the rest of what I can say.
Exactly.
This is computer numerical control, and it is kind of a server host architecture. And when those were originally built, you didn't have a lot of memory, and so it's built to a very complicated, weird standard where everything has an address. And so if you want to change this thing, you almost need to know what the numbers are. With Marlin, of course, we're working with numbers. You do kind of need to know those G codes, but your slicer knows them. And you can look them up. And it's a little less complex in that way.
It's the common language we all know.
So when we're building it, it's like we could, I want to think of it much more in a modular way. Mm-hmm. And that's what we're kind of doing is as things get built from that top down and from that bottom up perspective, we sort of start to create these little separations. And so things become their own little unit. And so we have like this LCD section is like becoming very much its own little, you could almost spin it off into a separate sketch. No Marlin, just LCD, and rip out all the Marlin and make a little LCD library that does all the LCD menus and all that stuff for your own thing. And then later that could be backported and become a part of Marlin again. But as you do that kind of thing, they become alienated from each other. And so it's always a question, how much do you want to do that? And again, talk about performance, that again sacrifices sometimes performance for that kind of stuff. So again, with the 32-bit architectures, Marlin 3.0 maybe, a whole new branch, build it from the bottom up, and then just start taking parts of Marlin that exist in situ and just bring them in and adapt them to that new code base. Maybe whole parts could be brought in, like all those G codes, one big blob could be brought in, but I feel like, it would be great to sort of just build it up from the ground up conceptually and with whole, have a thing called a stepper, which represents a stepper motor and all the things that pertain to what a single stepper motor needs to know about.
So now you're going object oriented with it.
I think it's a good way to at least get the picture, build something like that, even if it's in Unity or, Unreal Engine or something. Like just make a model. I sort of did that once. I built a model of a Prusa and I'm meant to finish it and will one of these days when I get to heaven. That's like the whole idea, model the whole thing from right down to the individual steps, moving the little teeth that move the little belt that move the thing, and just model it inside of a game engine. And then build, and then you can like run your firmware inside the game engine on top of it or whatever. People have done that. There's a thing called SimAVR, and there's a Sim RepRap, and they're out there, but they're hard to build, and I've never gotten them working. So if anybody wants to try and get that stuff working and build it and run it with some version of Marlin, that'd be really hip. I'd love to see that simulated stuff happening on my desktop, because you can build Marlin for Linux and run it in Linux. You just don't have anything to attach it to. So
we just have to start using all those GPIOs on our Pis.
Yeah, you got to start. That's what it's for. So you can use all those GPIOs on your Pi.
Okay. So that was our short answer. So this will go till 11.
Sorry.
That's all right.
Lightning round. Here we go. All right. Lightning question.
Let's see. Where does Marlin need the most help from a development standpoint? In terms of like if you could get a developer, if you were hiring developers, who would you hire? What part of the code would you be looking to work on?
I would be getting someone to help me with the website / configuration / auto build stuff. All of that is sort of like the tool which brings it all together. That's going to give you an interface right there for not only building, which you already have, but then for configuring Marlin with all the info on the screen in graphical form, images and diagrams and everything, a picture of the bed as you're adjusting your settings with the little grid on it that shows here's where your home is going to be when you home, and everything graphically shown to you so that there's no confusion about what your settings mean. And in a way, kind of put those files in the background. And so I have a lot of the architecture in place to get that, but it's just like a time sink. So I just, that's the thing is someone who likes jQuery, who likes Visual Studio Code plugins and Electron and kind of working in that realm. JavaScript, it's all written in JavaScript. So, and HTML5 and CSS.
Okay, so it's not with the actual firmware. You would just like more support personnel.
Yeah, I mean, ultimately it comes down to like these are huge like elements that like are going to make such a big difference in the user experience.
Right.
And they matter as much to the project as the code, which, you know, we're constantly patching up and keep working. Like it works well. Now, you know, can we make it a little easier to deal with when it doesn't necessarily work well, or when you're trying to start up and come to it for your first time? Like, I want to make that approachable and be like, okay, it used to be a one button experience to just run Blink on your Arduino. You know, can we kind of bring that back for something like this and make it more discoverable as well? Like,
okay.
A lot of people don't know some setting exists. Now it would be categorized and you'd have a picture next to it that says, hey, look, there's a picture of a thing. Here's skew compensation or backlash or whatever. And, oh, you can do that. I didn't know that. And they would just describe it. All that kind of stuff would be nice. People who have, you know, a little time on their hands, good graphical skills and stuff. There's some funding available to fill in those gaps. So it'd be nice to do that. But yeah, it's just a lot of time. As far as the firmware, and I'll keep this part of it short. As far as the firmware goes, really it's just keeping up with issues and patching the little bugs that people report that are easier to patch, because those can be a lot of people can see exactly what's going on and know, whereas someone who maybe just a casual user has reported a bug and doesn't. So it's like a little more help in the issue queue and just kind of like in the Discord, a lot of conversations going on. Get more involved, I would say.
Okay. So I'm now going to stop with my questions, even though I've got more, because I do want to give people time, and maybe we'll do this again in the future if you're up for it.
I will do, actually.
So let's see what else we've got here. I'm going to go through some of the stuff from the recent past. I'm not going to go very far back. Let's see, what did we have here? Again, I'm not going to go too far, otherwise I'll miss new questions. Let's see. We have. Yeah, I would definitely say, just commenting on some of these as well, there's no silver bullet. It's a lot of tuning and tweaking, and it is still a machine, and you have to find out what works best for your machine and your type of printing. Because I would definitely go on to say that if I'm printing a Batman bust versus a lot of project boxes that are square, my settings are going to be very different on my machine.
Yep, I would just, treat your machine as you would your lover.
Whatever that means. Whatever that means to you.
Don't go over. Find that edge, but don't go too far over it. I
gotcha. What we got? So S curve and junction deviation is okay, but no linear advance. Right. That sounds fine. If you do S curve and junction deviation, as long as you leave linear advance off, it sounds like you're okay. Yes.
Yeah.
Okay.
A complicating factor it is.
So if anyone's got questions, go ahead and be posting them, and I'm going down the list now. Benefit of linear advance is faster printing, and it allows for less retraction. Yeah, I think that's what we covered. Let's see. See, Keith B says that we need a bug feature bounty program.
Yeah.
I think that would be good. I think it'd be good for people to get to vote on, what sort of thing we want to have next in Marlin.
Yeah, I mean, someone assemble a team. Get right on that. Because I know that like sometimes I'll put out there like who's interested in this kind of thing. I'll put some idea out there. I was thinking of what if as your print gets taller, maybe your slicer can do this, but you should probably have it maybe reduce the acceleration or speed a little bit.
Mm-hmm.
Because your bed is moving and shaking, and if you got especially the tall tower, remember that's actually a calibration print. You just print the tall tower; it's very skinny, and by the time you get to the top, it's like shaking all over the place. If you can get your printer to not shake that top of that tower, that would be kind of cool. So yeah, I mean, it'd be nice. Let's float some of those things, or ultimately, what you do is you put them in, and then it would be nice to have some way to be able to tell how many people have some feature enabled in their config, but. Send us your configs and we'll we'll put them in a database. I don't know. We could do something like that, and we'll figure out how many people are using XYZ features or whatever. But yeah, you need to know.
Let's see. We got. Are there any tutorials for various settings? I'll answer that quickly, and then I'll let you add on to it. Yeah. Obviously, YouTube is a terrific resource for that, because a lot of YouTubers have taken the time to outline their experience with it. And the other place I go before I make a video is I go over to the Marlin website, and a lot of the times they've done a write-up on it. Now, they sometimes are more technical than watching a YouTube video where they walk you through it. But the technical information I usually find is on the Marlin website.
Yeah, and trying to find videos that correspond to different features and then put them on the page. Mm-hmm. So like if you go to like M7219 for the matrix display, or those little matrix LCD LEDs, I made a little video for that and then put it on the page. And then I've linked to some Chris Riley videos. But yeah, and also on the YouTubes, that's the best. That's one of the best places, obviously. Right. You can always search for something, and you'll probably find it. If you go searching for Ender STM32 or whatever, you'll find 3 or 4 videos just on putting a STM32 in your Ender and then tuning it. And there's a lot of good videos now on just going through Marlin like settings. Chris Riley's been slowly making his way through a lot of them. As pertinent. So the knowing which ones to ignore makes a big difference too.
Yeah, his videos are great, and I've wanted to do them on my channel, but have avoided it a little bit. Just people, the too long didn't watch crowd loves to attack videos like that. Not that should keep me from doing them, but
I mean, I like the in-depth ones a lot because one of the things is you realize that there are pitfalls, and I'm glad that he took the time to show me what not to do in addition to what I might have what to do, because that can be a big issue. So as far as tutorials, I want to definitely get more of those. So as people make those, definitely let us know, and I'll put them up on the Marlin site and link to the videos and stuff on the pages. Like if you just decide to do a feature on some G code, I'll do a page. I'll link to your video on the G code page.
Okay.
And stuff like that. So we can.
At this point, I think I'm more focused on like a individual printer, getting it working the best in which version of software, and going through those settings. But I watch Chris's videos as well. So if you're not familiar with Chris's Basement, go check a look at that. He's got a great channel, and so does Teaching Tech. He does a good job too.
Yeah, anybody who gets really in depth and but not and yet keeps it concise is just like blows my mind. They do it well. Yep. And they spend the time to do it right. So check it out.
So let's see. Do you still have the Marlin t-shirts up? Someone wanted to know if you still have those available.
I have a number of t-shirts in a pile here that we couldn't get rid of. We didn't quite pick the right sizes. So if you need anything under an XXL, I probably have a couple of each of those things. Probably mostly in the medium and small and kids sizes at this point.
Okay. But, so send you a message or
give them away. Send me a stamped envelope and I will send you a t-shirt. It won't necessarily size or color you want, but
what's the best way, and we're going to cover this a little bit when we get into just the closing of our video here, but what's the best way if someone wants to get in touch with you?
Well, I guess we also have a Teespring. So you can put a link to that if I can find it.
Okay.
The best way to get in touch with me is, if you have issues, do report them directly to the queue so that me and other developers can hit on them. And then Discord is a great place to, if you ping me there, I'll see it within a day or two. I'm almost always, there a few times a week. Emails touch and go. Sometimes I check it, sometimes I don't. There's those, but I would say those are good. Those are probably the two best ways. It's if it's directly pertinent to something, put it on the GitHub, and if it's something you just want to talk about, talk to me on Discord.
Okay.
The Discord Marlin Firmware channel.
and I can add that to my list of ways to contact you. I got all your social media links in the description of the video if anyone's looking for those.
Right.
I don't see any of these questions. Marlin adopting strategies like reducing. Let's see. Yeah, with Marlin adopting strategies like reducing res when low on Q, could Marlin produce indication that happened? User could correlate versus printed results, like a log or something like that. Is there some way that we can be notified that something was skipped or that some change was made to our expected G code?
I see. Well, I mean, the only time you would see that is under your like min segment length or something like that, or min steps per segment. So, for example, it's basically the minimum steps that you would ever want to do on your printer anyway. So this is like, and the chances of hitting it are quite low if you set it to 0. But it's basically, or 1. But the idea of that setting is like, if, for example, you got 80 steps per millimeter, and you never want to go below 1/100th of a 1/80th of a millimeter, then you never want to go below 1 step. So most of the time it's set to something like 5. So it's like a 1/16th of a millimeter or something like that. So, the more your resolution matters to you, the lower you should set that. But be careful, because again, on 8-bit processors, it won't, that's there basically to keep the machine from blowing up.
So I think the question was, is there any way to get notification when it happens?
Yeah, I mean, I'm not sure.
Is there a verbose settings that you can turn on or something like that?
Yeah, I mean, there isn't. For one thing, it's like, to find out that it happened would be kind of tricky. It would be like adding more overhead to the routine that does the stepping in that sense.
So you'd be slowing down something that's trying to avoid slowing down?
Yeah, I mean, yeah, it's a little weird. I mean, I could definitely add something to that. I mean, certainly you could just throw in a serial echo at in the if statement there. It's just like making that a regular feature that throws out a serial echo at that point. I mean, it would cause it to happen more. That's kind of the problem.
No, and yeah, I mean, if you're not familiar with writing firmware, the whole idea of adding prints of any sort or adding anything that takes up extra clocks slows down the operation you're trying to debug.
Yeah, I mean,
which is a bad thing.
I could toggle, make that one of the max 7219 things. Like, so if you have your matrix attached, your max 7219 matrix, then it will, light up all, the whole thing will light up or something whenever it drops.
Oh, you got like Christmas lights going in the background when you're printing.
The best way, because that has very little overhead, only the cost of setting a pin.
Right.
Or in the case of that max SPI, the way that one works is it'll update later. If you're inside of an it'll update later. So you can set the pixels all you want, but they won't get updated until after the interrupt exits. And there's a good reason for that, because it's over, like, it's a shift register based thing. So yeah, but yeah, you can do some tricks like that. I don't know if I would add that as a standard notification, simply because it's kind of a geeky thing, but I could definitely add it for as a developer geeky thing.
Okay,
maybe a good feature to have.
So I think I'm going to wrap up here. We've gone over our hour and a half, and I appreciate everyone for sticking around with us. We have stuck around. I think most of the audience has stuck around with us the entire time. So I appreciate everyone in the chat sticking around. I don't know how many people are watching on Facebook, but we got about almost 50 for most of the time on YouTube. So again, I'm going to...
Friends are all here.
So we're going to wrap up with the support questions. Are there any companies currently supporting Marlin?
There are a few. We've received very generous support for a long period of time from Creality 3D.
Oh, that's nice.
Of Shenzhen, China.
Okay.
We have received recently begun receiving sponsorship through GitHub from Prusa Research.
Very nice.
And very much appreciated at a very crucial time. And then there are Big Tree Tech has joined the throng of supporters also on GitHub at a high level.
Nice.
For a long time, Aleph Objects was helping us out, Lulzbot, But they had to leave and have not rejoined. But we assume they'll be back. They'll be back. They're not just doing clearance. I know it. They're making new revolutionary machines, and they're going to need new firmware. So I'm sure they'll be back. And let's see, who else? There are a few others, and I don't want to be leaving anyone out.
Okay. So yes, you can check. We do have some of the printer manufacturers helping out.
Yeah, they're all publicly listing themselves on the GitHub sponsors page.
Oh, good. I'll go check that out.
Patreon page. So you can go and thank them personally, as I do every morning when I wake up alive. Work with plenty of work to do.
I want to come back to this one next time. So what other ways can individuals support you? Because we've talked about companies that are supporting you. We've talked about people contributing directly through, submitting source changes, or if they can help with any of the bug hunting or web work, anything like that people can contribute to. Yep. So what other ways can people help out with Marlin?
Well, we've received generous help from manufacturers and vendors who needed help with their firmware by sending us the machines they needed help with. So that has been good. So, if you're a vendor or whatever and you need some help with something, having the actual hardware has been helpful. We then, usually turn these around by donating them. They're going to go off to some school or makerspace as needed, or some new user who needs a printer.
Terrific.
So, they definitely go to good homes, and that's a good thing. And boards also, and that kind of hardware has been very useful. We got donations from Trinamic of stepper drivers, and being able to test with those has been great, because we have lots of boards, but then they've got all these empty slots, and we got to put drivers in them. So that's your drivers. And things like that. Of course, I have the Patreon and the GitHub sponsorships, and those help us keep a roof over our heads. And we're actually, at this point, with our workshop is pretty well put together. I've been structuring it well, but where we are now is a little bit kind of inconvenient. So we're looking to get a little bit out of not inconvenient in the sense of being not, we have access to all the amenities and stuff, but it's just sort of in the midst of neighbors, and we can't make as much noise as we would like, and we kind of need a space where we can start using CNC and stuff. So we're looking to get a little bit of a space outside the mainstream. So your donations will help us sort of ease that transition, and then carry us forward to the next stuff when we have a little bit of a bigger, brighter, higher ceiling space. So it comes together.
So I have made sure that all of his links are in the description of this video. If you'd like to get in touch with him via any of the social media platforms he's a part of, or if you would like to donate directly to him and help with future Marlin development, go join Patreon like I have. And I noticed the other couple of people in the chats are also saying that they're Patreon supporters of yours. So,
yep. And what I forgot to mention, yes, do testing. Be a tester, just play with it, have fun, try everything, let us know if it works or is broken. That's okay. Help. So
excellent. So I appreciate it. Thanks for joining me today. Thank you for taking your time out of your schedule tonight.
Yeah, it was great to join you. I've been an avid fan of your stuff as you've been getting more geeky.
Well, I'm trying, and I appreciate it.
I appreciate the reviewers and stuff, but it's when we get in depth that perks up my ears and makes me pay attention. So
I appreciate that.
Yeah.
So thanks again, and thank you for everybody for joining me. I will have more videos out. Maybe one this week, but probably next week, since I got that one out Monday. As you know, guys, I don't have a schedule. It's whenever they get done, because I have a day job and 3 kids and all that good stuff. So yeah, it's when they get published.
Yep, he's a fabricator in many levels.
Yeah, so I've got these guys coming next. The SKR boards, the Mini E3 V1.2, the Turbo are both going to be put on the Ender 5 Plus here.
Yep. Take a peek at those MOSFETs. See, they're all stable.
Oh.
Want to make sure all our MOSFETs are stable.
Well, luckily, at least my board MOSFET is external, so that's not going to be a problem there. No overheating of that onboard one. This bed's too big. It would probably blow it anyway. So again, hey, and if you want to support my channel, I guess I'll plug myself here a little bit. I have a Patreon as well, so go check that out. And I appreciate it. I've had great Patreon support so far, and I appreciate all that. It helps parts for this thing keep coming in, and the videos keep coming out. So again, Scott, thanks, and I've got more questions, so we'll do this again sometime soon.
All right, I'm sure there are a lot.
All right, thanks everybody. Thanks for joining us.
Night, everyone.